Hello, so let's see if you got the problem correct yesterday. Here's how we should do this. So the rate of the forward reaction is going to depend on the concentration of both A and B because it's talking about the probability that A not only is there, but it also depends upon the presence of B, and they've got to collide together at just the right amount of energy to be able to form the two C molecules. So therefore, the reactants are dependent both on the concentration of A and B, and the reverse reaction is dependent upon C, the concentration of C, but we got to think of it like this. Really, when I write 2C, what that means is two molecules of C are formed. In order for the reverse reaction to happen, these two C molecules have to collide together to form A and B. So, therefore, it's much the same. So how do I represent that on an equilibrium expression? Well, as you probably remember, KEQ is equal to, and I know this is terrible, but it's equal to product over reactants. And so, therefore, I need to think about, okay, what are the products and what are the reactants? Well, let's start with the reactants. The reactants go on bottom because they're a little bit easier. So I'm going to go down here. I'm going to go the concentration of A times the concentration of B, like so. And that's how I will determine that. So like so. Now, the products, however, is going to be a little bit different. Because I am dealing with C, and it's not just one C, it's not going to be this, contrary to what maybe you wrote. It's going to be not that. The reason why is because you have to have two C molecules collide together to form A and B. So therefore, it's a probability of two C molecules. So therefore, it'd be like C times C, which we can just write as this. Here's a general rule when writing equilibrium constant. When you have a coefficient out front of a molecule, that becomes an exponent in the equilibrium expression. That's because there's two times, like you got to take that times that to get its probability that it's going to collide in just the right amount of energy. And so this would be the equilibrium expression for the simple equation A plus B is in equilibrium with 2C.